Hello. Today I am presenting our research titled Carving Up the Curb, Evaluating Curb Management Strategies for Ride-Hailing and Ride-Sharing Activity Through Simulation. The guiding question for our research was, how do varying levels of pickup and drop-off activity impact the curb and adjacent traffic flow? And can these effects be investigated through microscopic simulation? In Vissim, we created 13 scenarios and applied these to 3 different curb configurations. The scenarios varied based on flow level, parking rate, and share of parking events that are pickup and drop-off. The 3 configurations studied were an initial configuration with curb general parking and double parking, alternative 1, in which we introduced a pickup and drop-off zone at each end of the curb, and alternative 2, in which the pickup and drop-off zones were doubled in size. We analyzed 31 hours of video footage from Atlanta, Georgia, to determine the dwell time of vehicles, distinguishing between pickup and drop-off and general parking vehicles, the pickup and drop-off share of total parking events, the parking rate, and the likelihood of double parking, and finally, the traffic flow. We divided the traffic flow into 3 different vehicle classes: general passenger vehicles, characterized by dwell times of up to 8 hours, pickup and drop-off vehicles, characterized by dwell times of up to 5 minutes, and through vehicles. We assumed that the attractiveness of pickup and drop-off zones was 100%, and, based on the data analysis, we also assumed an average double parking rate of 40%. Finally, we recognized that the data analysis and model calibration was carried out on a limited dataset from a single location in Atlanta. As for our results, we found that though the delay increased as flow increased, it was minimized where pickup and drop-off zones were introduced. We also found that the introduction of dedicated pickup and drop-off zones significantly decreased the double parking rate. And finally, we found that the percentage of parking requests declined was dependent on both the share of pickup and drop-off events and the size of pickup and drop-off zones. Based on this, we can conclude that the separation of curb uses appears to be effective in reducing delays and optimizing curb utilization, particularly in high pickup and drop-off share contexts. We also find that a shift away from a long-term parking towards greater pickup and drop-off activity could lead to an observed higher curb productivity and lower occupancy, though higher rates of double parking were recorded in our simulations. Finally, we find that the use of dedicated pickup and drop-off zones may reduce the likelihood of double parking and associated delays. Thank you.